So, Vikram, shall we start?
Yes. So, as you know, we have been discussing a lot of like very interesting, at least we hope are interesting to you as it is interesting to us, concepts from finance, mathematics, computation, and so on. But it's not just enough to hear about it, right? You have, in order to understand it, you have to also work out problems. And as you know, the course comes with a weekly problem set. So, what we are going to do here in this segment is to start discussing how to go about solving similar type of problems as the problem set, right? So we are going to be recapping several of the issues that we have kind of like already seen, but in the framework of a problem that somebody is facing, right? So the first problem that we are going to discuss is related to this concept of bond pricing, right? So let's imagine that we have a situation where you have got Mira, who is in a place called Artharam. It's a place that we have made up. And there is a treasury bond of Artharam, and that is being offered to Mira at a price of rupees 99. Okay. So, what are the features of the bond? So, it has got 100 rupees face value. It pays a 7% coupon semi annually, and it matures in 2 years. Okay. And we what do we know otherwise? We also know that comparable bonds in the market are yielding 8% per year compounded semi-annually. So the question that we have to answer is whether the dealer's price fair. Now, the first thing that we want you to kind of like understand, and if required, you should refer back to the videos or the lecture slides, is that there is a lot of jargon associated with how we discuss the problem, right? And this is something that you have to be very comfortable with in terms of the jargon, right? So, for example, what does the word face value mean? What does the word coupon mean? What does the word semi-annually mean? What does it mean that this is maturing in 2 years? So all these things should be very, very clear to you, right? It should not be that you are trying to guess or you're trying to ask somebody what it means, because by the time you reach the problem set or even the exams, we are going to assume this is second nature to you. So again, if these things, any of these terms are not clear, this is a good time to pause the video, go back to your slides or video, make sure that you understand it. If you have questions, ask in the forum or so on, right? Okay, so let's go about thinking how to analyze this. So obviously, in order to find out whether the price is fair or not, what we need is a pricing formula, right? And we already have seen how to go about doing it, right? It's just that we have to translate the information that is available here in a way that we can express it in the pricing formula. So, what is the thing to do? So, remember, there is a 7% coupon, and this is going to be paid in two installments. How do we know it's going to be paid in two installments? Remember, it is semi-annual coupon, right? So 7% annual coupon paid in two installment means that basically you are getting 3.5 every 6 months, right? So over 2 years, remember this is a bond that is maturing in 2 years. That means that you have got these four coupon payments, right? At 6 months, you're going to get 3.5. 12 months, you're going to get 3.5. 18 months, you're going to get again 3.5. But at the end of the second year, you're going to get this coupon payment 3.5. But remember, you're also getting back the face value. That is what the face value is, right? What you are going to get back. So that is this rupees 100, right? So first thing you do whenever you've got a situation like this is that you write out what are the cash flows that are coming in at different time periods, and what is going to be the money that is coming in at each of these time periods. That's step one whenever you are answering. Well, okay, step two. Step one is making sure that you have understood each of these terms, what it means, right? And then once you have translated it into that, you're in a better position, right? Okay, so that's kind of like the situation. So now what else do we need? Well, we have the cash flow, we have the timing of the cash flow. We need the value of R, right? So where do we get the value of the R? So that is coming in from the fact that, remember, comparable bonds in the market are yielding 8% per year, right? So this is 8% per year. Again, we have to translate it in terms of what it means in terms of 6 months, because remember the cash flow is coming in terms of 6 months. So that is actually then corresponding to 4% per 6 month, right? So therefore, what we end up getting is that now we have all the ingredients that we want to put in the pricing formula, right? So again, if you don't remember what is the bond pricing formula, go back to your slides or the video and look it up. So you have got, remember, it will be sum of the cash flows divided by the corresponding discounted value, right? So here, for example, the first cash flow is going to come in 6 months. So you're going to discount it by 1.04. So 1 plus R corresponding to 0.04. And then the next one is going to come in second period. So in general, for period K, the discount factor is 1 by 1.4K, right? So this is how you do the pricing formula, and then you just use your, you can use R Python or you can use a calculator, and then you end up getting this expression that it's approximately 98.19, right? So this bond is going to be worth 98.19. Remember, the Mira was being offered this at 99, so the offer was a bit more expensive than what the value of the bond is, right? So definitely that means that Mira should not actually, accept the offer at 99. She should either negotiate or she should say, look, this is not actually kind of like thing, and do that, right? The other thing is also kind of interesting that you also have the rough idea of this from the fact that you have this 7% coupon. This was a 7% coupon, but comparable bonds was being offered at 8% coupon. So that's also something to kind of like also think of, right? But you would also need to calculate this exact numbers, right? It's not just enough to say yes or no. It's like, what is the exact price at which you can say yes or no, right? So that's something that is also there.
So,
Yeah.
Bikram, I just want to make one more, just very small point. So,
Hmm.
3.5 is the amount I'm going to get 6 months in the future. 3.5 is the amount I'm going to get 1 year in the future. 3.5 is the amount which I'm going to get in 1.5 years in the future from today. And
Hmm.
103.5 is the amount I'm going to get. These are my future payments.
Right.
And after discounting this 3.5, which I'm going to get 6 months from today, the current value of that future payment is 3 rupees 36 paisa.
Right.
Right? And then we can see it in that way. And then 3.5 rupees that I'm going to get 1 year from today, that 3.5 rupees future payment, current price of that is 3 rupees 23 paisa or 24 paisa. This is
Right.
the current price. 3.5 is 3.11, and this 103 rupees that I'm going to get 2 years from today is the current price is 88 rupees 47 paisa. Now, if you add all the current value of these future payment stream, that add up to 98 rupees 19 paisa. So that's how, and that is why we are calling this future payments the price we should pay if we value it at a 1.8 or 8% yield per rate. The payment should, like, the value of this future payments is current price should be 98 rupees 19 paisa.
Right. Right. So there's also another interesting point. So one way of thinking about what does the word T stand for in the general bond pricing formula is to think about it as T as years, right? So T equal to 1 would correspond
Sometime
to
in
1 year,
future.
and T equal to
Um,
2 would be 2 years. But
Correct.
here, if you notice it, we are not using it as years, right? So for
But
example,
it is,
when
yeah, understood. It is a number of payments,
period,
basically.
number of periods, right? I think
Period or
that's how you
number
are.
of payments that
Yeah,
I'm getting.
right,
Yeah,
right. So we are basically kind of like treating each 6 month as a period, right? So the
is
first
a
period you're
period.
getting
Correct.
3.5, the second period you're getting
Correct.
3.5 square and so on, right? So that's another thing. One final thing before we move on from Mira is one question that we have had is that, we had this as like 8% comparable rates are there. And these are typically, a function of government policy also. As we had seen when we were looking at the yield curve, they change, right? As a response of like government policy. So if you remember, the current yield curve that we had in the slide was different from how it was looking 6 months ago compared to how it was looking 1 year ago, right? So
Right.
in this example also, we can actually think about one thing. So suppose that the comparable bonds are, rather than trading for 8% per year, they are suppose, it changes to 9% per year, right? So then how exposed would this bond be to the rates moving? So then you can actually do the same formula again, right? And if you
Mm.
kind of like, instead of 8, this 0.4, you will have this 0.45, right? So if you do that, you can do the same calculation again, and you end up getting that this is going to be 96.41, right? Which is
Mm.
1.78 lower compared to earlier, right? So this illustrates this general principle that basically you have got that prices are going to fall whenever the rates rise. So you have got this inverse relationship between interest rate and the price of bond. As the interest rate goes up, the price is going to fall, and that's actually one risk that is always there in terms of a bond, right? When you have this interest rate changes.
Correct. Correct.
Okay, I think then we can move on to our next problem, which is about, no, I think it was already there, which is about at the bottom of the page, Tarun.
Huh.
Right. So this is I think this problem basically deals with like this different compounding conventions that we talked about, right? So we have Tarun who has 100 rupees and a 1 year horizon, and his bank is quoting 8%, but there are different kind of like creating schemes that we have. So you have already seen this in the slides, but let's just make sure that we have understood this, because this is the obvious point, but as we said, fairly simple, right? So again, if it's created once a year, he's going to get 8%, right? So therefore he would just get 108 at the end of the year. But if it's created semi-annually, then he's going to get 4% at the end of 6 months. So 100 becomes 104. And then on that 104, he's again going to get 4%. So therefore, you end up getting 108.60. And if you have this creating monthly, you have the same idea, but now instead of 1.04, we have got at the end of first month, you're going to get 100 plus 1 plus 0.8 by 12, right? Because it's like now divided across 12 months. And then you are going to get interest on that on the second month. That will accumulate to add to your amount, and then again you are going to get interest on that in the third month, and so on, right? So as we discussed in the lecture, if you take this process to the limit, then you are going to get this answer that we are going to get this 100 into e to the power 0.8, right? So this is an example we had seen before, but we just wanted to make sure that you understand how we are moving this, and this is coming from this limiting idea, right? So again, this is a spread of about 0.33. And as we discussed before, that if you kind of like change the horizon, then that will basically lead to a increase in this spread, basically, right?
Mm.
So I think why don't we take a pause before we discuss the next problem, which is related to this portfolio optimization problem.
Sure. Sure. Let's come back after 5 minutes.
Sure.